Lecture on the scientific method in determining effectiveness of an educational technique, something that teachers do. So let's just imagine we're up here in the left-hand corner. Imagine there's two awesome kindergarten teachers, and they develop a new technique for teaching kids how to say the names of the letters of the alphabet. So they have this great alphabet technique. Their students are succeeding really well. They've taught for years, so they're really surprised at how quickly students are able to learn with this new technique. They want to share it with everybody, so they want to publish it. They want to get it out there. But in order to get people's attention, they need to show people that this is actually not just them and their classroom, but something that anybody can get results with. And that's a big concern, because one of the things that we know is that the influence of personalities of teachers, just their experience, the things that they know, their way of interacting with kids has a huge effect on outcomes in their classrooms. So despite the fact that they used to teach the old way and they're teaching this new way, we want to learn whether it's the new technique that they're teaching the alphabet with, or if it's just them. So we need to do a kind of test on that. So one of the things that we do is we have to look at a before and after approach to things and test something that we value. So with alphabet letters, one of the outcomes that we would test, or sometimes called the dependent variable, that's a term that you're going to be tested on. We want to test how well students just name letters of the alphabet. Like if I give them a sheet that has random letters of the alphabet on it, can they name those, whether they're uppercase or lowercase or whatever? So that's a test that's really typical for late preschool, early kindergarten, and early first grade. So we give them this test before anything happens at all. So for example, at the beginning of their kindergarten school year, we give them a test before teachers do anything to see how many letters they already know. And then the teachers do their teaching technique. They get in, and this is the independent variable. This is the thing that they want to check. Does this get in the way and make things different? So they do their teaching technique, and that might take 2-3 months. It might take the entire school year. So they'll just do their routine, and then afterwards, they will test that same outcome again. They'll give the kids exactly the same test again, the same kind of test, not the same test with exactly the same configuration of letters, but the same kind of test that you gave them before. You give them that same kind of test after, and see how many letters each kid names this time. And that should give you, that before and after, a sense for how much your kids grew because of the teaching technique that you put in place. So that's part of the story with scientific research and education, and that's really important. So I want to emphasize this idea of before and after. And so we tend to call that in education pre-testing and post-testing. So where were kids before you got to them? Where were they after you got to them? And what did you do in the middle to help them get there? So that's a key part of the scientific method in educational research. But we're going to come down here because there's a whole bunch of problems with just looking at the before and after. So the first thing that we worry about is, well, yeah, of course kids are going to grow all the way through kindergarten and being able to name letters of the alphabet, and there are dozens of reasons that they might get better at reading, at being able to identify and name letters of the alphabet. So just looking at these two groovy new teachers and their fantastic new method doesn't give us all the information that we need. What we have to do is compare the growth that these guys got by checking their before and after to a control group that does not get this teaching technique. So we give them the same test beforehand, that dependent variable. We just give them a sheet of random letters and ask them to name them one at a time, and we see how many they get correct. And then the people in this control group just do no new technique at all. They just do what teachers have normally been doing for decades with teaching the alphabet. So, and we double check that to make sure they're just using regular methods that don't really look like what these two new teachers are doing. And we don't give the control group any of the information on this new technique so they don't actually try to sneak it in or something like that. So same thing, that group, after they have had their school year, we test them again at about the same time that these kids get tested, so about the same amount of time has passed. And then we check how many more letters these kids know after than they knew before. So what does just regular garden variety teaching look like for letter naming outcomes? Then what we do is we compare these two groups. And that's what I'm looking at down here at the bottom. This group up here, who got the fancy new teaching, is called the treatment group. They got the treatment, the new thing that we were trying to test out. And this is that independent variable. And with those kids, we checked before and after, and we want to know the number of letters they were able to name before, the number of letters they were able to name after, and we want to find the difference between those two things. So we just do simple subtraction. How many letters did each kid know before? How many letters did each kid know afterward? And then we do exactly the same thing for the control group. We check how many letters they knew before, how many letters they knew afterwards, and what's the difference between that for each of the two kids. And that's what growth is in this case. Growth is the number of letters that the people in the two groups knew by the end of the year. So imagine a kid knew only 10 letters at the beginning of the year, and by the end of the year they knew 15. Growth would be 5. So same thing over here. If a kid knew 17 letters in the control group and by the end of the year that kid knew 27 letters, then that would be a growth of 10. So if I have a class that has 30 kids in it, that's great. I can line up all of that growth and look at it and see how well kids grew, and I can just add all of that up and divide by 30 and I'll get my average. So if I add up all of the growth numbers, 5, 10, 17, 4, 3, just add all of those up and divide by the number of kids, I'll get my average amount of growth over the entire school year. And that's interesting. So I can check that. And if my numbers for the control group, the growth looks smaller than the growth for the treatment group, then I start to get a little bit excited because it's like, oh, my treatment actually seems to have gotten more letters on average in growth than people who just did regular garden variety teaching like we were doing before. So there are all sorts of other reasons that might explain the differences between growth among these two groups, and that's where statistics start to enter into play. I'm going to stop this video and dig into some charts and graphs with some mocked up numbers for alphabet growth. But I want to let you know right from the beginning that if you're going to do statistical checking to see if the control group and the treatment group, the differences between them are really significant and powerful, you're going to have at least 30 people in each of these groups for the math to work out. Otherwise, the math is just, it's not as robust. And if I really want to check this well and make sure that no other factors inside the control group or the treatment group are going to kind of kick out my results statistically, I really want a lot of kids in each of these groups, 700 to 1,000 kids, so that I can think about factors like preschool, home language, poverty, and that type of thing. Some of those other factors can explain some of these things. So I want to be able to kind of segment out those groups and start talking about whether those things are explaining my growth rather than the actual teaching technique that we're trying to examine here. So educational research can be pretty tricky. To get 700 to 1,000 people in a group of kindergartners, I might need as many as 25 different classrooms participating with me. I might be able to just take my class, my morning kids and my afternoon kids, and somebody else in my school, morning kids and afternoon kids, and get 30 kids and do a decent statistical study. But if I really want to know whether this teaching technique works, I want to do a pretty large scale study with 20, 25, 30, 40, 50 classrooms so that I can do the math that I would need to show whether the differences between the treatment group and the control group are really significant. And that's where I'm going to stop.